Hi there, here's my little monster creation. He's in progress. So 3D printed little finger segments, a little bit of basically dental floss, it's black, and some paper clips join these little joints that I 3D printed with some craft elastics on the back to give them a little bit of flex back. And down here, I'm like a puppeteer. When I pull these strings, stuff happens. But I don't want to be a puppeteer. I want to give this little hand some muscles, if you will. So you may know what these are, you may not. These are called servo motors, or just servos. And where you see them a lot is in remote control planes to control the surfaces. Now what a servo is, there's a little DC motor in there and a gear pack. A servo moves through 180 degrees of motion. So this little arm will move up to 180 degrees, and you can control that quite narrowly. Now, what I am planning to do is I've hooked up 4 of these guys, and my hope is to connect it to my Homer Simpson hand that only has 4 digits. And each one of these guys, when I want them to, will go zzz, and they will pull the string attached to each of these digits. So that's going to take a wee bit of doing, and then I'm hoping I can control it through a microcontroller, but we'll see where we get to. Okay, so here is my homemade flex sensor. Here's a servo that it's hooked up to, and watch this. When you bend the servo, or bend the sensor, the servo responds. So I hook this up to Mr. Hand. I should be able to control it. Okay, so that's set up. May not be pretty, but it is so cool. How neat is that? Okay, so I've got my little muscle servos numbered. I've numbered my digits. Index 1, thumb 2, middle 3, that guy over there 4. And I'm going to look at number 1 here. So here is a little exercise we need to pull off. When I pull Mr. Tendon to pull, I need to know what distance does that tendon need to go through. So when I measure it, I find that, let me test, it's about 19 millimeters. So my next trick or calculation that I need to make is, I know that these servos, they work on rotational motion. So I know that this tip is going to come back. Now this comes back to a little geometry calculation. How big is the circle, the diameter of the circle that I need to get this guy over here to make that pull happen? So I may need to lengthen this arm, or if the arm is long enough, I need to know where to attach so that I can move through that almost 19 millimeters of distance to give it the pull. So we'll get back to you and I'll let you know what I find out. Okay, back to geometry. if I take the center of the servo and I measure to the furthest arm, or furthest hole on the arm, I find the distance is almost 15 millimeters. Now, if you remember, I'm trying to get a pull of 19 millimeters. So the good news is I don't have to extend this arm. It is long enough to use, because if that tip were to go all the way to here, I'd in fact have almost 30 millimeters of pull. Now, the next consideration is, do I attach it to the end and just go through a partial rotation to get my distance? Or do I hook it in somewhere closer to the center of the circle? Well, again, coming back to mechanical advantage in levers, the challenge is if I attach it way out here, this little motor has to do a lot of work, because if you remember, the longer the lever arm, the more force is applied. So as the tension pulls up on the finger, it's going to be hard for this little motor to pull it way out there. I think I'd be better off to pull it in the attachment point and allow this little motor to use a lesser radius to go through more of a stroke, I guess it is, through more of that circle. You'll have more mechanical advantage or less resistance on that little motor, because it's going to be straining to do it as it is. Okay, so I needed a way to attach my servos to the arm. So here's what I've come up with. These are actually plates for welding helmets. They're little protective plates, polycarbonate, strong. You can cut them with scissors, and they're quite adaptable. So that's what the plate looks like. So the next step is to hook up the servos, get them going. See you soon. Hey guys, here's my robo build. So far we've got our tendons threaded, fingers work if you pull the cords, and now what I've got set up is a servo bank. And the idea is each of the 4 connections to the 4 digits attach into a servo. Now we're learning already that you can't push the servos too far, otherwise you burn them out. So number 1, he's failing right now. So for the time being, we're going to use 2, 3, and 4. And I've written a simple program just to test their actuation. So if we watch, they're going to go from rest to middle to full pull, and then back to kind of middle. So with those all working in concert, that should pull those fingers once I tighten these knots up. So stay tuned, we'll see if it works. Okay, the bowl clips aren't pretty, but they're holding those cables. Let's see if this works. Oh, there the fingers go. Both servos are straining. Yeah, so the trick is going to be, can these servos handle that stress? We might have to change where the cords are attaching and where the swing arm is to kind of reduce the pressure. Okay, some progress. What I did is set the servos so that they're, when they pull fully back and the fingers are fully tensioned, then I set the string to the fully tensioned position and rewrote our script. And watch what happens now. Come on. Not so much tension on the servos now. They're not straining at that half mark. Much smoother. Okay, here's my little robotic hand, and here is my homemade flex sensor. I've rigged them together, and watch this. I bend my finger, Roby bends his finger. How cool is that? So I've only got one finger hooked up right now, but in theory, I can hook them all up. Do, 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 do. And I'm way over here, and he still goes. Okay, the evolution of Mr. Hand. So what I've done is put flex sensors on a glove. So I got 2 fingers working so far. Ha ha ha. Now, one little oops is I've always kind of treated this guy as a left hand, and I grabbed a right-handed glove. So what you might notice is when I lift my index finger, the left-handed index finger raises, and when I raise my third finger, it's actually opposite. So now that I've sewn this all together, I could swap this for this and re-sew them. I don't think I'm going to do that though. I'm going to change the contacts, but 2 fingers. Hee 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 hee. Hey there. Here is my glove with some homemade flex sensors. Here is our robo hand, and now when we lift index finger, middle finger, hey you, come here. Have to adjust that 1/3 finger. He's a little slow to respond.